Okay, in this video I'm going to show you how you can solve quadratics by factoring. One of the key concepts behind solving by factoring is called the zero product property. It is very simple but yet so powerful, and it's one of my favorite things to use when doing math. So I think you're going to like it. It's called the zero product property. Now, one of the cool things about the zero product property is it's very intuitive, and I think all students kind of understand the basics behind it. What it means is if you have any product, so any two things multiplied together, let's call them just A and B. If I know that the product is equal to zero, it stands to be true that either A is equal to zero or B is equal to zero. And if you think about it, there's no other possible way that two things can multiply to be zero. It's impossible otherwise. So it has to be that one of these things equals zero. Now, the reason why the zero product property is so great is that if I give you a quadratic that's already factored into a product of two binomials, let's say it's like x minus 3 and x plus 4 or something like that. So you factor it into this, and it's set equal to 0. Well, here are your factors. Here's one factor multiplied, right, by the other factor. And if you know it's got to be equal to 0, then it's got to be true that either x minus 3 equals 0 or x plus 4 equals 0. So if x minus 3 equals 0, that means x equals 3 could be a solution. And if it's x plus 4 equals 0, and I used to take away 4, that means x is negative 4 is a solution. So these would be called either solutions or roots. And even when if we wrote it as a function, this would be called zeros, and we'll talk more about that in a second. Now let me just show you why this works again. If I go back, because this is super important. If I go back and I check x equals 3 into the original, and I put a 3 in for x in the first binomial and a 3 in for x in the second binomial, you can see what happens here. 3 minus 3 turns into 0, and 3 plus 4 turns into 7, and of course 0 times 7 is 0, and it gives you a true statement. So therefore 3 works. In a similar fashion, negative 4 works, because if you put a negative 4 in for x, the first binomial turns into negative 7, but this one becomes 0, and of course 0 equals 0 is true. So that's why x equals negative 4 is also a solution. So I guess the key to using and taking advantage of this zero product property is to make sure you have a product, meaning your quadratic has to be factored, right? That's why we're spending all this time learning how to factor. So I'm going to show you a couple examples. And if you know how to factor, this is actually quite simple. This is like the payoff, right? So let's try to solve the following. Let's look at a couple. For A, let's try to solve x squared minus 5x minus 36 equals 0. Now, the first thing that has to be true, if I'm going to take advantage of the zero product property, is I have to have it equal to 0. Must be set equal to 0. That is absolutely huge. Now over here, this is not factored, so we're going to have to factor it. So if I use the wheel, I'm going to put a negative 36, I'm going to put a negative 5, and two numbers that multiply to make that true. Let's see, I think maybe a negative 9 and positive 4, right? That multiplies to negative 36, that adds negative 5. So I can factor that into x minus 9 and x plus 4 equal to 0. Now we get to use the zero product property. I'm going to set x minus 9 equal to 0, and I'm going to set x plus 4 equal to 0. If I solve this one by adding 9, I get x is 9. If I solve this guy by subtracting 4, I get x is negative 4. So these are my solutions. Let's take a look at another example. Let's call this one part B. let's say I have 4x squared equals 25. Now you're going to learn actually in the next couple lessons another way of solving this, but I'm going to go ahead and use the zero product property. Now remember, the first thing that you want to make sure you do, number one priority, is to set your equation equal to 0. It's got to be set equal to 0. So I can do that by simply subtracting 25 from both sides of the equation, right? And if I do, I have 4x squared take away 25 set equal to 0. There's my all-important 0. Now I have to factor. Now it's only a binomial, but I notice there's subtraction, and 4x squared is a perfect square of 2x, 25 is a perfect square of 5, so I can rewrite this as a difference of squares. 2x plus 5 and 2x minus 5 is the factorization. So if it's set equal to 0, one factor I can set equal to 0 is 2x plus 5, and the other one is 2x minus 5. And if I solve this one by subtracting 5, I would get 2x equals negative 5, and if I divide by 2, I get x is negative 5 halves. In other words, negative 2.5. On the other hand, if I add 5 to both sides, I'll get 2x equals positive 5, and if I divide positive 5 in half, I get positive 5 halves, or positive 2.5. So there are my solutions, negative 2.5 and positive 2.5. Let me show you something else that is going to be quite useful. Let's take a look at finding the zeros of a function. So let's call this example 2. Finding the zeros of each. I'll do two of them with you. So let's call this part A. For A, let's say I have the function y equals x squared minus x minus 12. So when it says find the zeros, guys, basically what that means is, let's think of this graphically. If we were to graph a quadratic, now I don't want to actually have to graph this one, but just a couple basic things. I know it's going to open up because the leading coefficient's 1, and let's just say, you know, again, I'm not graphing that for real, but just to illustrate, if I wanted to find the zeros, that's really like saying find when y equals 0. So if y equals 0, I think you would agree that would be that coordinate here and that coordinate here. I don't know the x value, but I know the y value is 0. Same thing with this one. I don't know the x value, but I know the y is definitely 0. So basically zeros are the x value that make y 0. They're also the x-intercepts if you want to think about them in that way. So basically, the moral of the story is we have to put a 0 in for y and find out what values of x make that true. And I think you'll see why this is in the same section. You're basically solving the quadratic by factoring and using the zero product property. So I'm going to skip the wheel. Let's see if we can just think of two numbers that multiply to negative 12 and add to negative 1. And I think we can do x, let's see, negative 4 and positive 3 multiply to negative 12. And if you add negative 4 and positive 3, you get negative 1. So that's good. So I can set x minus 4 equal to 0. That gives me x equals 4 as a 0. And if I set x plus 3 equal to 0, that gives me x equals negative 3 as a 0. So actually this drawing might not be too terrible. This would be like at 4, right, if we were actually graphing this one, and this would be at negative 3. Those are the zeros. Let's do one more example. I'm going to do part B. What if I had f of x equals x squared plus 12x plus 36. Okay, for this one, let's see if we can figure this out. So don't freak out if you see f of x. Still want to replace that with 0. It's like another way of saying y. Now, if I think of two numbers that multiply to 36 and add to 12, I'm thinking 6 and 6, so x plus 6 x plus 6 I think will do the trick, right? So in this case, they're both the same, so I don't need to solve two equations. If I just simply set x plus 6 equal to 0, I'm going to get negative 6 both times. We'll talk later on in another chapter about what that means, that we have really, if we set this one equal to 0, we'd also get another negative 6. But for right now, there's really only one 0, and it's negative 6. That would be our solution, or 0, for this problem. Now, for your turn, I want you to try the following. Let's see if you can solve this one. X squared plus 5x equals 14. Be careful that you have it set equal to start off with. And for part B, find the zeros of the following. Y equals x squared minus 10x plus 25. Thanks for watching, guys, and good luck with these.